challenge given to the students today was to come up with a best design for a rocket that would launch an egg up as high as possible and make it land safely. And this is to emulate a potential future Mars mission, because that's what Mars landers have to do. They have to go up and they have to come back down very hard. So that was the goal. And what we hope the students would do, and what they actually have done, is to come up with innovative ways of doing it. They come up with their own ideas. This was their rocket and they tested it, and sometimes they worked and sometimes they didn't, which is what we've seen. Yeah.
The biggest problem for me was probably like the weight, because if it was too heavy then it wouldn't even go up, and even if the design was really good, if it was too heavy then it just wouldn't work, so it's all about the weight.
Probably just designing the rocket so that they would actually work, because we've gone through a lot of different designs, some of them failed and some of them have gone well.
We kept the string the same length, but we made a bigger parachute, and we also used a lighter fabric so that we could get more surface area, and it will be less heavy as it goes down, so hopefully it should go down a bit slower. The egg's alive, I think.
Basically, we tried shooting it with the parachute, but when we hit it down, it smashed. It's a quail egg, and inside it's just smashed.
What's the objective of this rocket? As well as going up, what's it got to do?
It's got to come down safely with our egg. The hardest thing in the challenge was just kind of trying to get everything together, making it as light as possible, and not making sure that the landing gear was going to come out. And we got quite worried with our parachutes because we weren't sure whether they were going to be big enough, being able to support the weight of the inner tube we have.
Well, the biggest challenge would have to be finding a way of getting the blades to spring up, and also making this light enough so that when the secondary charge comes out of the rocket motor, that it can actually be fired out of the rocket.
Obviously, we had to test with these ideas, and in the prototype, the original design was much bigger, and I would say the biggest challenge was definitely getting it down small enough to fit inside a much smaller rocket than what we originally intended. The prototype carried a lot of weight, and again, as Jazz said, you need to shed all that weight and sort of still have its effectiveness. So this essentially is the landing gear for our rocket. We are using a gyrocopter mechanism for it to give a little bit of lift as it falls to reduce the downward force on the egg. Inside we've got the egg on on sort of like a hammock connected to a spring, and as the secondary charge of the rocket motor goes off, it sends the capsule out, the wings will open up, catching air and start spinning, and then just in case all else fails, we have a small cap with bubble wrap to cushion the blow.
This is the original prototype for the gyrocopter. This doesn't have the spring mechanism, but it did, and it does have much larger wings. This was also designed to carry a heavier weight than the new gyrocopter design.
Why do you think the smaller one might be spinning
Not
fast?
this Monday, like next Monday. Like a fortnight. All right then.
So, what's there more of when it's falling faster?
Lift.
Yeah, well, there's more air going past it faster. It's falling through the air faster, so there's more air getting rushed through it, so it spins faster.
I think the best part of the project was coming up with an idea, and then instead of the teacher or supervisor saying that you couldn't do it, the only way that you found out that if you couldn't do it was actually to try it, like actually build it, see if it works.
To the National Space Museum in Leicester. That was exciting. Yeah.
There was like loads of little like artifacts and things around, like and there was like experiments and stuff you could do and try out to see what, like give an example of what it would really be like if you were on a rocket, like how there was something you could show what it would be like to launch. So there was a camera and you could see the people in the rocket, but they couldn't see you, so you had to tell them how to launch it by telling them to press the buttons, but you had to sort of explain it to them because they couldn't see what you were doing.
My favourite bit was probably the trip to Airbus, because that was quite early on, and we went to the wing assembly stations and all that, so that gave us a few ideas of what we could do, because that's how professionals do it. So
I wanted to create an exciting and engaging project for the students who took part. I chose students who just finished their GCSEs because they're in that crucial stage where they're going to be making decisions about their future, and I wanted to give them a chance to meet and work with real engineers and to find out how they got to where they are and the kind of choices that they need to be thinking about making. I chose to work with a mixed group of students because I think there's a big problem with uptake from girls taking up engineering, and so I thought it was really good to have a mixed group.
The Marauder, because a Marauder is something that brings trouble in it. Really, we think it's going to have trouble with the ground, but hopefully things will turn out okay.
For the rocket motor sorted out, yeah?
Oh yeah.
Have we got our disc ready for that?
there you go, sir, behind you.
Lovely. So
The difference between the two rockets is that one of them is going to be landing the egg with a parachute and the other is going to be landing it with a gyrocopter. The one that's going to be landing with the gyrocopter is going to have a wider diameter for the body of the rocket, which means that it may not go as high, but it just needs to hold the gyrocopter.
The hardest part of this challenge was for the students to consider the materials and the way that the rockets were constructed, and this required them to build up their designs via a series of prototypes to get to the final design. And this is really emulating what real engineers do in real life. They work from the basic designs, proof of concepts, prototypes, through to the final project. And so that really tied in with the overall aim of this project, which is to get the students to consider perhaps engineering as something they might want to do in the future.
6, 5, 4, 3, 2, 1.
That's amazing.
And it's in perfect condition.
The egg, perfect condition.
Perfect. Oh, it was brilliant.
It was brilliant. Yeah, apart from being pretty much laughed off at the beginning and having huge doubts before it went off, actually deployed pretty well.
Everyone thought it wouldn't work, and then as soon as I saw it go up, my heart sank, and then when it deployed, I was just like, yes.
Yeah.
Such a good feeling.
Could not contain it.
Yeah.
When it finally deployed and you just see it spinning down.
It's brilliant. And it was only spinning for about a couple of meters and it just landed so nicely.